Hey guys, how's it going? So today I'm going to be talking about Qwen 3.827b. However, this is specifically the one that is using the DeepSeek harness. So I ran Qwen 27b for about 4 days straight. A caveat, I did have some issues with DeepSeek harness, and I will mention them here and how to fix them. So first of all, what is it that we're looking on screen? So this is basically the first iteration that Qwen 27b did for this project. Now, what is this project? The project is called Tower of Druaga. So this is basically a anime that is kind of niche, but I wanted to make sure that I capture some sort of architecture. And because this is a niche anime, all it has to go on is text online usually. It doesn't know too much about the anime. Or the game, I guess. There's a game. So this tower is supposed to be 2.2 kilometers across in diameter and about 6.6 kilometers high. In perspective, the clouds are about 2 kilometers tall. So this tower would be much taller than the clouds. Now, per the anime, this is just part one of the tower, but we will not go into trying to render the second part of the tower. The tower itself is supposed to have 60 floors, and the first floor is supposed to have the city of Meskia. And so this is a large city in the center on the first floor of the tower. It is inside the tower because outside the tower there's a bunch of like demons and monsters. And so it is safer to be inside of this first floor. So I asked Qwen to go ahead and start a project rendering this. Now, this project also runs on a loop. However, unlike the prior video where I'm concretely giving instructions on how to render the Parthenon, everything else, and basically telling it to do such and such, and then in loops I would tell it pretty much to keep improving. In this case, my first, I don't even know if I can actually get to my instructions here because they're so long. But in this case, what I've done is I've asked Qwen 3.827 billion to create a architecture as well as design the loop system to architect this out. One of my specifications was, however, that this be the most largest file that it could make in a single file. Now, I opted to make sure that it is a single file, not because that this is smart or that it is easy for AI to do this. It's actually pretty hard for AI to work in a single file because it is so massive, it would have to start searching inside of it. Now, the final result, which I didn't show you yet, and you guys can jump to that if you want to, is about 1.1 megabytes in size. And that is quite large for a file that AI uses. Usually, the files that AI creates are relatively small in the 25 kilobytes, maybe 40 kilobytes if they're large. So this file is about 1,100 kilobytes, about 18 to 19,000 lines. Okay, let's go ahead and talk about some of the stats here. So this is running on a 5090. You can see the tokens per second average here is 130. It was running for about 2,176 minutes, whatever that is in hours. And the input-output tokens are 666 million input, 13 million output. So for whoever knows about input and output tokens, there you go. This took about 150 turns. That means in the context length that I have here, which is 200,000. So there's 200,000 tokens in a context length. It reset that 150 times. It also spent 6,552 steps or iterations in that time to go ahead and improve. Most of this time was spent on searching inside of the file because it's so large it cannot fit it into its context window. However, the main point is that this 27 billion parameter model at quantization and I can't even say it, NFFP4, so Q4 basically, for the 5090, that took about 4 days. Now, I want to talk about some of the pitfalls of the DeepSeek harness before and how I fixed them. First of all, the cache hit rate percentage is missing because of the inference engine. It does work with other engines. So this is just specifically for this engine. Probably can patch it in, but there's no point because it is working. The other thing I wanted to let you guys know is the pitfall where it would not compact. So there are some issues with the way that DeepSeek was trying to call and talk to the Qwen 27 billion parameter. By default, it is sending a high reasoning tag to the model. So that is default. And because the second it gets to, let's say, 150,000 token limit, it stops to compact. It tries to, but because the model thinks so much, there's no more room to compact. And so its thinking process during compacting fails. And so it could never compact, it gets stuck. So the workaround for this is to go into a separate chat window here, just say hi, and go ahead and request it. Unfortunately, I have to scroll all the way up here. But request it to go ahead and look through how the compaction is working. And the model itself corrected it by making sure that Qwen 27 billion is sending a non-thinking, non-reasoning compaction request to the inference engine so that there is no thinking when it tries to compact. And so once it did that, and it basically did all this correction on its own, you can see here, this is all the chat that it was working on. It made goals. It tested it out. As you can see, it probed 140, 160, 175. And eventually, it ensured that it could generate those compactions. It tested the non-thinking reasoning traces and applied the fix. And so this fix is now working also in my other chats, and it's permanent inside of DeepSeek Harness. So one of the major things that is important in DeepSeek Harness is that you can fix a lot of things. You can ask the model itself to go ahead and do something about the harness system and modify it, and it will do that. The other thing I wanted to mention that there are things here called trajectories, which you can look at where the model is failing, what it's doing, what calls it's making, etc., what turns it's making, and when. So there's also background job requests, and it can split out into subagents as well. All of this makes DeepSeek Harness very powerful. The most powerful thing I do have to mention is the way that it summarizes its compactions. And I guess what is the way to show you guys how that's done? Let me show you one of the compactions here. I might not have it. But I would really want to show you guys the compaction. So I guess let me just describe what it is. A compaction is at the end of the context window, it has to summarize what it has done during that time frame, whatever your context window is, 65,000, 32,000, 200, 150, whatever it is. During that time frame, the model itself will go ahead and summarize its process and then list all of the things that it did and what it should do in the next stage. So it's basically telling itself in a very dense format with like arrows, like it's a very dense formatting, what it is doing itself. And so because it is trying to do this, and all harnesses do compact, the difference in the DeepSeek harness is just how efficiently it compacts. So these are not compactions, these are injections. So it injects its own context. And you can see just by the sheer volume of thinking bash scripts that it's currently doing. The other thing that I asked the DeepSeek harness to do, which is the fourth thing now, is to ensure that the thinking does not get added to the context window because it would balloon. And so what DeepSeek has done is modify its own script. I believe it just said that it's going to monitor the context window using the NInfer, the backend engine, because in the backend engine, we opted not to have the thought process injected back into the context. So what it's doing is taking that number, this 133K or whatever, and grabbing it from the NInfer engine instead of estimating themselves. And so that really assists in how many basically tokens it can use during during its context window. As you can see, it will think, then it will decide what to do. We'll do a bash script, then it'll think again, right? So all of these thinking steps don't get injected back into the context. And so you would be shortening the context. As you can see, like the thinking is quite long on what to do next, but the actual output is quite short. So as long as you don't inject it back into the context, you kind of have quite a bit of room. So going over some other things here. Yes, I think this is the outcome, context injection. And you can see it's basically summarizing all of its completions here, like R97 completed, what it did during this process, and then what has to, happen next. And then it sets its own goal. So it sets an objective, basically. It's saying, basically, the next objective is X, and it creates its own goal lists and continues from there. You don't actually have to set up a goal list. As long as you can tell it, set up a goal list and objectives, and it will do so on its own. So it is quite smart in doing that. If you do want to set up a goal list, you can actually type in goal, and then set your own goal. However, you don't really need to do that. You can actually just type it out and it will do it on its own. Okay, so this is some of the things that I wanted to mention before we continue. All right, so some of the things that it did add to the project, this Tower of Druaga, is, I'll list it out. There is an external spiral ramp as one of the requirements. Meskia is floor 1. Clouds are atmospheric. There is crowds, creatures, traffic, and particles. There's cinematic camera presets. There's post-processing, adaptive quality. Everything is in a single file, which is more than 4,000 lines. There are procedural assets rather than downloadable art packages. So everything is created inside of this HTML file. there are basically hundreds of things, hundreds of objects. Okay, there. Let's just continue. Let's just continue. Again, this is the example of the compaction that we found here. Primary request. It's in this kind of format. It's very good. As you can see, it's not meant to be read by people. It's just being read by the machine itself. So it's very dense. It doesn't eat away at your context. Very good stuff. Okay, now I do have 9 generations of this Tower of Meskia because it does go in steps, and basically every system it adds, you will see it improve. And so this is the first one. This is just the general layout of the tower. It starts off and it does add all the controls you can see here, 1 through 6, but you can't really click on them. It created the tower. Nothing else works. Okay, let's go on to the second one. So this is the second iteration I saved. It is basically a tower. You can see that there's a city here. I incorrectly actually told it to put the city on the outside so I can see it. It was building it on the inside, and this was my mistake. It actually cost me quite a bit of time to fix this later on. So it was my mistake if the tower looks different than it does now. But this is what it opted to go for. In this generation, it does have flying cameras. It does have a day-night system, as you can see, but it's not very good looking. All right, let's continue on. So now that it added a bit more light, there are shadows, as you can see here. There's time of day, there's the sun, there are some lights around the city. And if we fly to 6, let me just put it to daylight and pause it here. Okay, 6, and as you can see, there's this entrance that's supposed to be for the tower, but it's pretty sparse. It's kind of sparse around, and yeah, it's much better though. Like, this is what it would look like to look at it from this distance. The one thing I do have to note is that we do have these tiny SVGs here, which we'll take a look at in a bit, but we don't have the ability to do that right now. I don't have WASD or anything. I just have basically mouse control like this. All right, so let's continue. In this layout, I don't remember what it did. I think that's, I don't remember. Let's continue here. Okay, now we actually have a render where I asked it to expand the tower so that we do put the city inside of the tower rather than leave it on the outside. It does make it a bit dramatic here, and we can see that there are these, tiny camels, and this is supposed to be a desert. So there are these tiny camels. They are moving. They're going towards the entrance of that tower. So if I were to go inside of it, and I do have a way to, no, I don't. Okay, if we go inside of the tower, we can see, let me just do that and change the day. Okay, we do see that there are buildings here, and we do have these birds as well, which is probably a bit hard to see. You can see it flying over here. There are like smaller clusters of buildings now. And we do have tiny palm trees here and some other assets. So we will see there's quite a lot of assets already being built, but it does look kind of sparse. But you can see the scale is quite something if we're talking about this kind of tower. Let's continue to the next iteration. So the next iteration, let's see what happened here. Right, so the next iteration, you can see there's a lot more density. There's a lot more buildings. And there's a lot more things, but I still can't fly around to see all of that. All right, then we get to the next one. So what's basically happening here? Oh my goodness. Okay, hold on. Let's pause this. I have, yes, I do. Okay, so I do have ability to fly around now. So as you can see, we do have quite a lot more density inside of the city now. And this is the most buildings I've seen. But this isn't like the major cool part. The other cool part is look at how many things that there are here. There's like palm trees, there's these people, there's whatever these poles are. And so this is a 27 billion parameter model. There's obviously these birds. There's multiple bird clusters. There's one over there in the distance. If you can see. And then there's another one there. What else do we have here? There's a variety of buildings. In the middle, we do have this pool of water. We have different kinds of stalls. We do have these smaller clusters of buildings, which kind of look like very poor, houses, I guess. I don't know if it has like multiple areas, but you can see there's so many variety of shapes and buildings that is what is making it kind of stand out here. Oh, and there is this tower here, whatever that is. This pyramid is still here. I don't know what this pyramid is supposed to be. The point of this generation currently is that there's just a sheer volume of assets, and they are arranged in kind of a poor way, honestly. And let's continue to the next iteration here. Okay, the next iteration is kind of an improvement on the interior, and it's a minor change. I'm just gonna continue to the final one now. Okay, so this is the final output we have for the tower. Now, the difference here is there's quite a lot of differences. So first of all, we have this sand texture plus, I think there's hills. I think there's hills as well. Let me just, something clicked here. There are sand particles. I do want to show you guys some of the monsters. There's like some tiny rocks, but oh yeah, so there's these tumbleweeds or something. I don't know what this is actually. They're supposed to be like demons and monsters that are procedurally generated outside. So let's just find some. There's supposed to be quite a lot of them. This is a rock. But because of the sheer scale of this map, it looks kind of sparse. Okay, here's one. So here is supposed to be some sort of monster. Now, individually, like these aren't the best kind of shapes. It's just because of the sheer volume that is impressive. Like I think there's like 20 plus different kinds. Yeah. And so I'm flying pretty fast, but getting nowhere because this tower is now about 5 kilometers in diameter. All right, let's use some of the cool things here. Okay, there's some flight camera maneuvers that we're going to do. We're going to bring down the top of the tower so we can see inside. And we'll just put the day maybe something like that. And we're going to fly inside, which is 3, I think. All right. So now that we're looking at this city here, you can see it is quite nice. So the layout, this is the final version. Let me click R to fly around. There we go. All right. So this is the entrance to it. It's this kind of corridor. And then you go in. And as you can see, we kind of have like these streets. And then that leads to the center. You can see that there are proper, pizza pie kind of orientations of these buildings now towards the center. In the center, we have a pool, and you can see that these kind of clusters of tiny houses, which were the first iterations of the houses that it created, it grouped them all in this center location next to this water. You can see that there's a bunch of stuff on the sides of the roads. And I didn't go through all of this. There's just too much to look at. But again, this is just the 27 billion parameter model at 200K context. But because it has like a looping system, which kind of makes the context irrelevant because it is infinite. As you can see, it's basically infinite. And yeah, so this is what it built. So this is the Tower of Druaga, first floor Tower of Meskia, if I'm saying that right. I haven't watched that anime in quite a long time, actually. It's quite a good one. All right, so this is the project that it was working on for 4 days, and it really came together in the last couple of iterations. Actually, today is when I finished. Just because of the sheer volume of things that it had to do, 96 different steps that it thought of, and then a couple of iterations to make it better. So yeah, I think the future models, and again, this is a smart model. It's not like a Fable model. It's pretty smart though, but it's not Fable level. But I would say that this result is quite good. This is probably like the last time I'll be using Qwen 3.827b currently until, I figure out a way to use it like a subagent. And I probably will be trying to get into some of these new models that dropped. So that will be my next goal, unfortunately. But I will still be using the DeepSeek Harness, I believe, because this elevates any kind of model that you use quite a bit further above whatever the base model is. So if it can go ahead and create this kind of output just through sheer compute, then, what can it do on better models? Now, I do want to show you guys a preview, I guess, of the next model, which is Qwen 3.8 Next. And this is basically a Pelican SVG that I create every single time to test what the model does and how much control, how much depth can it think in advance to create and vector graphics. Vector graphics are difficult because they are math, and you do have to position all these things in relation to other objects. So you would have like a circle, etc. And they're vectorized kind of 2D graphics that can use some animations, but it does involve quite a bit for the model to go ahead and render them. So I do like to first start out in trying to, do a sort of Pelican or any kind of other image. Obviously, this is benchmarked, and the Pelican has been benchmarked for quite a while. But the point of it is, even if it's benchmarked, the output quality still has to be relied upon the model itself, and any kind of deviation from the coordinates will make the output different. The other thing about, I guess, benchmarking on SVGs is it does generalize to other things. If it knows SVG, it can generalize to creating buildings, as you saw, and creating water, etc. So it does generalize in some aspects. And I have tried these models with SVGs that are completely unrelated, which I do not want to post on the internet because then it will be benchmarked. So I basically look at the Pelican SVG. But the point of it is, this is the Qwen 3.8 next at Q4. It will be quite good, I think. Basically, this Pelican is one of the best Pelicans I've ever seen. If you look at my eval lab here, this is the Qwen 3.8 2.4 trillion parameter, so like a more order of magnitude larger. And this Pelican is worse than the one we got. So this is again 3.8 Qwen 3. I think this is Qwen 3.8 something. Either way, this might have been the online version. This is BF16 Pelican. So this is the BF16 Qwen 27B 3.8. As you can see, it's pretty simple. And I do have, I believe, a couple of multi-pass versions. And so multi-pass versions, basically same as the Tower of Druaga, will increase detail, not based on like the original vision of it, but based on like extra details. You'll see like bugs and flying birds there. And the way that the model increases detail with extra passes. So again, this is pass 1. So Pelican pass 1, it's pretty good from the 27 billion parameter. And this is 4, where's the 4 passes? Yeah, this is 4 passes. So this is the same model, BF16, but it got 4 attempts to iterate and improve the Pelican on the bike by just saying add more detail, make it look better, or make it look better, basically. So it goes ahead and tries to make it look better. So yeah, if this is now the 1-pass standard for the new models, then all of our kind of outputs are going to be elevated that much further with the DeepSeek Harness. So now that these models, these tiny models, 27 billion parameter models, have reached a state where they can think and plan in a very long context, as you saw, 6 million output, by dividing its context window over many different cycles in a project. It can work for multiple days at a time to finish its output. Now, if you don't think, the Tower of Druaga looks as good as some of the other projects, or it doesn't have enough shaders, the main point of it was there are just so many things inside of that file. It's 1 megabyte file, 1,000 kilobytes, that the sheer volume dictates the quality. And if you were to get obviously a better model, its one-shot capability might be prettier. You can expand its context window through DeepSeek Harness, and it could operate on a much larger context window and plan further and give more detail, etc. So I think if you haven't tried DeepSeek Harness, this is basically the star of the show. In addition with the Qwen 27 billion 3.8 that is now able to output so much volume, plan ahead multiple days, and kind of generate these outputs that are on the level of and hitting against like much larger models. If you want to go ahead and try this on your own, ask one of your AI models online or otherwise to set up a plan to design the Tower of Druaga from the Aegis of Uruk in a single HTML file and see what you get. All right, thank you so much. This has been my test of the multi-day operation using Qwen 27B and the DeepSeek Harness. And I think this is a pivotal moment in local AI where they're able to do quite a bit more because of these two combining forces. I hope to make other videos in the future. I have cool projects that newer models create, such as the 3.8 Flash, Next, the new one that just came out, GLM 5.3, the Max version, as well as the smaller version. I am actually downloading them right now, so they are quite big, so it will take some time, but hopefully I will get something else cool out for you guys shortly. Thank you for listening. Please go ahead and comment below. I'll try to read all of them and answer you if I can. Thank you so much. Have a good one.